Hi, Jackie.
Hi, Soleil. How are we doing?
I'm so good. I'm so excited to learn all about space junk and how junky they might be or not.
I,
Which actually, oh yeah, just looking at the chat, there's a great question right about that. It's coming from Alicia about what exactly we're expecting to learn today.
yes, Alicia, this is going to be a very modern conversation that we're going to have on the very modern visual tour. And you're going to learn all about the functions of these satellites, where they are, why they're there. And most important, we're going to build up to this for the end, why you should be paying close attention and possibly why you should be a little concerned about all of the stuff that's currently in space. You're going to get all that information wrapped up in today's program. So I'm gonna start with another introduction because it's not just me giving this program. I am joined by the amazing Deion Desir. Deion, shout outs here. Deion's here.
Hey, how's it going, everyone? It's a great pleasure to be here showing you all some cutting edge science visualization. I'm tuning in myself from Brooklyn as well. So shout outs to Kings County and also shout out to Ego Academy, where I'm usually teaching. Shout out to all the educators, really.
Yeah, so Deion is an earth science teacher in Brooklyn, and we wanted to actually do a little promotion here too, because Deion came through a master's program at the American Museum of Natural History. That's how we met. Deion was actually a researcher in my research group for a summer. And we have an open application right now, right, Deion? People can come and join this same program if you sign up right now.
Yeah, check out that link because MAT was one of the best, fantastic opportunities that you're given, especially in New York City. It's one thing for teachers to be, lecturing and talking about science, but it's a whole other thing for teachers to be doing the science. It's really, really awesome. So MAT, check it out. It's an open application right now, and you've got nothing to lose. It's a really fantastic program.
Yeah, and it's fully funded. Plus, you get a $30,000 stipend as part of it, and you get to work with amazing educators and scientists. So follow the links in there. But let's get started on this program, which is going to be one of my favorites, I'm sure, because I love this topic. All right, so space debris, space junk, space satellites. There's a lot of words we've been throwing around here for what we're going to talk to you about. All of those words are going to be valid, and you're going to see how. And we're starting here over New York City. Deion's got us set up. Deion, where are we right now located?
We are over West 81st Street right now, looking over Central Park, looking to the east. This is Manhattan, New York.
And we should say that what you're actually looking at is software's rendering of New York. It's called Open Space. It's a NASA-funded project. We've been doing a lot of work at the American Museum of Natural History on this. We have a lot of partners, though, both internationally and domestically. And you can download this software yourself and play with the same kinds of data sets that we're going to show you today. So check out OpenSpace, the openspace.org. Now I can't remember what the full website is, but you'll see it in the chat. It'll be right there, openspaceproject.com. Okay, so here we are over New York City. This is a nighttime sky that you don't usually get to see, and it's actually a dusk. The sun is still a little bit up. We're going to set the sun now. So Deion's going to set time to move forward very quickly. What do we have time set at here, Deion?
So time is set at 5 minutes per second. And so as it gets darker and darker, this is much more what we hope to see in New York. Though if you're here, you know that's not always the case.
It's definitely not always the case, but that's okay. So the stars are coming up, if you could see them. And this is my obligatory take to tell you to go outside and look at the nighttime sky whenever you can, because it is amazing, even in New York City. And as we're going up, so you're probably used to, if you've ever looked up, maybe you noticed a couple of stars. Maybe you know some of your constellations. Maybe you know the planets, that they're a little bit different than the stars and how they move. The moon, that's an obvious one. But Deion's going to put something on right now that you might not be used to looking at. And so, Deion, why don't we turn on the active satellites? And we're going to pay attention to how you guys are reacting in the chat. Did you know this was more of your nighttime sky? We're going to return to this by the end, where I'm going to tell you all about why we should all be concerned about this look. But I'm going to break this down for you first. So you're looking at now not just the nighttime sky with stars brightened, but we're also showing you the satellites that are orbiting the Earth right now. And Deion, remind us again what time is set to?
So time is set to 5 minutes a second. So every second that passes is 5 minutes in the simulation.
So immediately I want you to notice that you can see different kinds of moving satellites in front of you. And that's the whole point of this program, to take you through what is this stuff? What is out there? Where is it? Why is it out there? How much of a threat should you think of this as? Does it pose a threat to your nighttime sky? And does it pose a threat to travel beyond Earth? And we'll hopefully answer some of those questions for you guys as we go along. But let's turn those satellites off and start into we're going to set you up with the rules of today as to what's going on with these objects, and set it up so you can get your bearings as to what you were just looking at. So Deion's going to take us as if we were on a rocket ship, our YouTube rocket ship here. We're launching off of Earth. We're going to get a perspective of the planet with the sun over there. We've got a nice view of the Earth here. And let's talk about the word satellite for a second. What does the word satellite actually mean? Well, the definition of a satellite is one object orbiting another. So you can have both natural satellites and artificial satellites. We were emphasizing the artificial satellites in that nighttime view. But Deion, you've got us set up here with a view of our natural satellite. And that pink line orbiting the Earth is the moon. It's our natural satellite. And I'll have Deion, why don't we turn time on so we can see how the moon goes around us? And what do we have time set to here, Deion?
So this is about 10 days every second now. So you can see things are zooming a lot more because it takes about 27.3 days for the moon to make a full orbit around the Earth.
And that is an important component of Earth science, right, Deion? Studying the moon going around the Earth and the moon cycles.
Mm-hmm. Full moon, new moon, all of that has to do with the moon's orbiting around the Earth, its natural satellite tendencies. So
important to this is that the thing holding the moon to the Earth, and this is rule number 1, is gravity. The Earth's gravitational pull is what holds the moon in the orbit that it's currently in. And there's lots of interesting things to talk about the moon, but the most important thing I want you to take away is that we have a natural satellite and it's held in place by the Earth's gravitational pull. But let's talk about rule number 2. So Deion's going to pull us out a little bit from this perspective, and let's have a look at the whole solar system. Because the other important thing here, and all of this will be applied to your take on these artificial satellites, is the speeds at which they go around our planet. You were probably seeing in the nighttime view, you had them, some were going around really fast and some were going around kind of slow. And this perspective gives you a little bit of an explanation for that. So that's the sun at the center. And you've got the inner planets, Mercury at the closest, Venus, the next one that's got kind of a reddish orbit there, Earth in the blue line going around, and then Mars. And just as a reminder, Mercury goes around the sun the fastest. It's closest to the sun. So it's rapidly going around. It takes about 88 days. Then Venus, Earth, we know, has an orbit about 365 days. Mars, a little bit further. That takes almost twice as long as it does for the Earth. That's more like 687 days. Keep going further out. Jupiter takes 12 years to go around. So what you're looking at in rule number 2 is that the closer you are, the faster you move. The farther away you are, the slower you're moving. And this is a rule of celestial mechanics here. So let's apply these rules, gravity and distance away from the planet for your speed, to the artificial satellites now. So Deion, why don't you take us in? We're going to head in back towards planet Earth. And as we go back in, what I want you to note here is that as we come back in, I want you to notice the space, because this is going to be an open question in this program. Is there a lot of space here to be launching a lot of material? it kind of looks pretty vast up here. It looks like there's a lot of space. The Earth looks like should be a lot of room up here, right, to see things go. But what we're going to talk about is highways, the highways that you're going to send these satellites on, that we're going to send them into orbit around Earth on. And we're going to talk first about the very first satellite that probably comes to mind for many of you. I'll give you a second to try and answer what's the first satellite, artificial satellite you might think of? What's the one that comes to mind? I'll have Deion turn the orbit on for it here. If we put this satellite on, there we go. There's a very famous satellite here. You can see it's very close to Earth. It's in this category of highways that I'm going to call the low Earth orbit highway. And it is the International Space Station. I see Jacqueline Barinti's answered Hubble, and it's very close to Hubble's another great one to guess, and it's in a similar-ish kind of orbit. But this is actually the International Space Station that we have here, which is in low Earth orbit. And this is where people are living right now. So this satellite of the Earth right now is also a kind of a house. It's a habitable place. It's been in orbit for 22 years. It was launched in 1998. And it's about 250 miles on average above the Earth. It moves at like 17,000 miles an hour. It takes 90 minutes for it to go around. So let's actually take a little closer look at it, Deion, because you can take us closer to one. And we're not going to be showing you close-ups of any other satellite, just this one, but in part because it's so spectacular to look at, right, Deion?
Yeah, absolutely. As we had paused time there, it was at 10 minutes a second, so you saw it zooming around. But yeah, it makes so many orbits a day that it gets an unbelievable amount of sunrises and sunsets. I'm definitely very jealous.
Yeah. And what I want to bring up now is secret number 2. We've got a couple of secrets we're going to be revealing to you as we go. But secret number 1 for this program is actually that the International Space Station that you're looking at right here is the brightest human-made satellite that you can see. So in your sky, it's actually as bright as any given star that you see in your sky, except for the sun, of course. It's not as bright as the moon, but it can get as bright as Venus does, which is the next brightest object after the moon. It's very bright. And we actually have a cosmic challenge for you guys. There's several websites that would allow you to locate it in your sky. Actually, let us know in the chat. Have you ever seen it? Can you spot it in your nighttime sky? It moves very fast, as we said, 90 minutes, and it's covered the whole planet. Its orbits is 90 minutes, so it moves really fast. But you can find it in your sky. And this is your challenge, our YouTube cadets here. Find the International Space Station. Deion, you should have the students in your class doing this too, right? We're going to have them looking for this.
No, absolutely. It's definitely going to be an assignment in the future. So if you're on I'm used to saying Zoom at this point, but keep your eye out for that one.
Yeah. Okay, so International Space Station, this object, low Earth orbit. Let's move away, Deion, and just get another glimpse of it as we go, as we kind of move away from it here. And by the way, there are 7 people on board right now, as well as one baby Yoda. They launched a baby Yoda with the last crew that went up, and I thought it was absolutely adorable when the baby Yoda came floating out of the into the space station. Okay, so we're moving away. That's one satellite that we're showing you, moving 17,000 miles an hour or so, 250-ish miles above your head. Now let's talk about, that's one kind of highway. That's a low Earth orbit highway. We're going to come back to it in a sec, but let's look at the other major highway of satellites. They're called the geosynchronous satellites. Now remember the rules. Gravity is holding them in place, and then the farther away that you are, the slower you're going to move. So now you're looking at these satellites. A position is a very important position. The geosynchronous, geostationary satellites out here are in such a position that they're about 25,000 miles away from planet Earth. And at that position, they can have an orbital rotation, an orbital period that matches the rotation of the Earth, which means that they can stay over a fixed point on planet Earth. Now, that has a lot of usages. This is why you see this little zone here, this highway of satellites is where we put communication satellites. They're placed here because antennas don't have to track them rapidly as they're moving across the sky like you do when they're in low Earth orbit. Weather satellites are put out here because you can do real-time monitoring and data collection. Navigation satellites are put out here. Your GPS satellites are out here. This is where you get a lot of action at about 25,000-ish miles away. Now you move slower. You're clearly moving at only about, this is about 7,000 miles per hour out here. And secret number 2 about this orbit is, I think, a fascinating one. And that is that it was the science fiction author, Arthur C. Clarke, who actually popularized the idea of using this orbit, this position, this geosynchronous position, in 1945. That was 12 years before humans had ever even launched anything into space. And it was published in a magazine called Wireless Magazine at the time. And the title of the article was Extraterrestrial Relays, Can Rocket Stations Give Worldwide Radio Coverage? It's fascinating to look at. And so we actually have another cosmic challenge for you guys, because Arthur C. Clarke is a phenomenal science fiction writer. He penned a lot of magnificent ideas. He penned the screenplay of 2001: Space Odyssey with Stanley Kubrick. And a short story was the driver for that. It's called The Sentinel. So we're going to encourage you guys to read The Sentinel. Read Arthur C. Clarke's The Sentinel. It's fantastic. And then follow that rabbit hole down and read a lot more of his stuff because it's wonderful. Okay, these are your geosynchronous satellites. This is the highway of telecommunication right here. And let's look at now another highway of these satellites. It's going to start building up on you guys. We're going to start seeing more and more of these objects out here. So back in towards the International Space Station. So you can already see that one's in there. This is a nice orbit because you're close to Earth. And let's turn on some of the other active ones in here. Woof! This just got busy.
Yeah,
right?
very busy.
Yes, it's getting a little busy out here. So this orbit is called low Earth orbit. So this is kind of between 100 miles from the surface of the Earth and like 600 miles is what's considered the low Earth orbit. And just as some distance reminders, because this is important for you to scale, like what are you exactly looking at? Mount Everest is about 5.5 miles tall. That's the tallest natural thing on this planet. Airplanes fly at like 9 miles above the surface. The International Space Station, when you see it flying around there, that's like 250 miles or so up. Low Earth orbit is where you've got a lot of stuff right now. And so why do you put things there? Well, I saw in the chat earlier, people did mention that they thought of the Hubble Space Telescope. So why do you use this orbit? 2 really obvious reasons, I think. You're close to Earth, right? So one, astronauts want to be there because you're both in space or enough in space that you can easily get back and forth to planet Earth. And we did put a very famous instrument there, the Hubble Space Telescope. And it was put there on purpose because in this orbit, you can get there and replace old technology. So the Hubble Space Telescope has actually been repaired and had instruments replaced a couple of times. This is also a good orbit for taking high resolution images of the planet. So if you want to take really high res pictures, you want to take them from closer to the Earth, bird's eye view kind of thing. It is a bad orbit for telecommunication satellites for the same reason why the geosynchronous, or for the opposite reason, the geosynchronous orbits were in a good place, because in these satellites move super fast across the sky. So the antennas on Earth have to move really fast to try and catch what's going on. Looks like we're going to have Soleil coming in here with a question, maybe. Soleil, were you coming in with a question? Or maybe not.
Hi. Yes, I am. Hello. Sorry about that. We actually have a really great question looking at all this activity flying around Earth. The question is from Maria Zia, and it is, can the junk in space come back to Earth, and does it cause any damage?
Yeah, that was Maria that's asking that. So Maria, actually, we haven't shown you any junk yet. This is all active, useful things. There's a whole other data set that we can show you, and we're going to show you a little bit of it that's just the junk. And they do work on the junk. So satellites have to have a plan when you're launching them and how you're going to get rid of them. So there's something called a graveyard orbit that's out there by the geosynchronous satellites. And sometimes you push them there so that they're in a safe orbit away. Other ones, you want them to be close by and then bring them back into Earth so that they burn up in the Earth's atmosphere. So anybody that launches should have a plan for what's going to happen when the satellite becomes inactive. So it's a great question from that perspective. And we'll come back to this debris question in a minute. But from this perspective, we're still showing you low Earth orbit objects. And I was mentioning that telecommunication isn't great here, which brings me to this very famous set of satellites that's launching right now called Starlink. So why don't you tell us in the chat if you've heard of Starlink? Give us a little clue here if you know what we're talking about here. It's launched by a company called SpaceX. And let's switch to, just Starlink now. This is just Starlink satellites. And let's turn those on, Deion. Yep. So what do we have time moving at?
So right now, time is moving at 5 minutes a second. Anything faster, and it'll literally look like a flurry of satellites. But this is just one mission flying around the entire Earth like this.
Yeah, and the background on this mission is that SpaceX, a private company which is run by billionaire and current richest human being on the planet, Elon Musk, has launched and is launching this constellation of satellites. So I said telecommunication isn't great here unless you launch in a net, unless you launch a constellation of satellites that will cover the planet. And that is the purpose of Starlink here. Currently, there's only about 1,000 of them up here. But SpaceX has been approved for up to 12,000 that will be up here. And Deion, why don't we show everybody what that looks like, why the net exists on these satellites. So the idea for these telecommunication net satellites is that they will cover the planet in coverage, in location, in coverage. And this will bring one of the main goals is stated as broadband high-speed internet to the entire planet. And you can see that he's only got about 1,000 of them up there, but there's up to 12,000 he's been approved, and they've stated that they want maybe up to 42,000. So it looks like you've got a question.
Yep, we have a question just about this, and you might already be planning to get to this question, but it's from Adam Trimble, and he's wondering why were these internet satellites allowed to be in low Earth orbit?
Well, they were approved by the FCC. At this point, the rules of space are, it's pretty much at its beginnings, right? And so Elon Musk and SpaceX have the technology. They had a plan, and you can do it. If you guys have a plan and you have the facility, you can follow all of the regulations and do this kind of thing. So there's no rules against it. No one technically owns space in the sense that it's a property. It's similar to the ocean, or at least that's how we're starting to see it. So that's Starlink. And while it may very well be a useful thing, man, there's a lot of material getting launched up there. So that's going to take me into really the next phase, which is going to get you into this idea is everything up here a good idea? Is everything that has been launched a good thing to have up there? And I'm going to tell you now about 3 things that may not be the best things that have launched. So let's pause time here, and I'm going to flip to 3 images that I'm going to show you. The first of which is something that was called the Humanity Star. And I'd love to see in the chat if any of you heard about the Humanity Star project, know what it is. This is an image of the Humanity Star flying through the sky. So what this is, it was launched in January of 2018. It was a self-described functionless satellite launched by a company called Rocket Labs, which is out of New Zealand, run by a guy named Peter Beck, which is a fantastic company for launching rockets. But this project, you can say your own opinions about this in the chat, and I'd love to read them. What they launched was a 3-foot tall, basically disco ball into space with the tagline that it was a reminder to all on Earth about our fragile place in the universe. It was bright enough to rival Venus. It was bright enough to be seen streaking across your sky very clearly with the naked eye. It was going to orbit for 9 months. Once it launched, though, the drag on it was not accounted for properly, so it quickly started to deorbit and burned up. But say what you will of it, this was launched. It had no other purpose than to do this thing about reminding all on Earth about our fragile place in the universe. Next thing launched that I would say I'd love to see your discussion in the chat about is called the orbital reflector. And we've got an artist's rendition of what it was supposed to look like here. Now, this was launched in December of 2018. It was launched on board of a SpaceX rocket. It was an art project. And what you're seeing on the right-hand side was the satellite, and that diamond shape that stretches out from it was like a diamond mylar balloon. Similar to the Humanity Star, the idea of this one was it was supposed to get people to think about life or the sky. I can't remember the tagline for it. It was as bright as the Big Dipper. It was supposed to be very, very bright in your sky again. Cost $1.3 million. Again, self-described functionless object, an art project that was commissioned with the Nevada Museum of Art. And what happened to this one, once it launched, it was launched with a cluster of satellites, and they lost track of it. They couldn't quite figure out which one it was because they had to tell it to deploy the mylar balloon so that it would inflate, and then you would be able to see it as it reflected sunlight. But it was during the time of the government shutdown. They lost track of it, and it's been lost. It never actually inflated, and has been officially, I think, declared space junk. So that was launched for just over $1 million. An interesting idea here, right? Then number 3 that I want to show you is this very famous object, the Tesla Red Roadster, with a fake space person in there. That's a mannequin. That Deion was very clear when we were talking about it. He wanted to make sure, right, Deion? This is
I mean, it looks pretty lifelike. You never know. So that's definitely a fake person. You couldn't be out in space for that long. Too much exposure to radiation and whatnot, right?
Right. This was launched in February 2018. It was a part of the SpaceX Falcon Heavy test flight to test out that rocket. It was an original red roadster, but you can see in this, it doesn't look so red. It's in part because it passed through some serious radiation as it left the Earth, and it had cameras on the front, on the sides. It was live streamed. It was a payload test as they were checking the quality of the rocket. And we're going to show you where that orbit went. So let's switch back into open space. So what's fascinating about that dummy payload was that it was sent on an elliptical heliocentric Mars crossing orbit, which means it's in an elliptical orbit. It's actually going around the sun. You can track it. You can see it. And I'll just another note, because I'm seeing people in the chat asking about the car. It was a Tesla Red Roadster that used to belong to Elon Musk. It was his commuting car. And what is the car there for? They had to send a payload. You have to send something heavy to show that the rocket can carry things. And so I think it kind of came from Twitter. Somebody suggested it. Elon Musk got inspired by it, and it's almost a marketing ploy that this Tesla Red Roadster is currently orbiting our sun. And you can see the yellow orbit here that's going around. Deion's blinking it. That yellow orbit is showing you the orbit of the Red Roadster. And what do you have time set at, Deion?
So this is 15 days a second. So every second is about 15 days in this simulation. And you've seen it cross Mars's orbit already. And we had started back in 2018 when we had launched it from Earth.
Right. And so you can see that it crosses Mars's orbit. And that's in part because Elon Musk and SpaceX have a very declared mission to start sending packages and sending people to Mars. We'll see. That's a whole different conversation. We'll see if that's going to actually be on the table. But more important now is for all of you to sit back and say, wait a sec, how much material is in space right now? So let's head back into Earth. Let's head back into Earth. We should have all of the satellites on. It looks like Soleil's got something for us.
Yeah, and I think as we head back into Earth, there are a couple cool questions, just thinking about how many things are out there. The first, about, are there any calculations to make sure things don't crash into each other? Another person also asked a similar question. So yeah, do things crash into each other? And if so, how do we prevent that?
Yeah, we're right into that question, because now what we're going to tell you about is, well, do things crash into each other? Is that something that might happen? And Deion's turned on all of the active satellites, right, Deion, that we have in here right now?
Yeah, everything that you see on the screen is active.
Oh, and I should say secret number 3 that we didn't blink. That was my fault. Sorry. There are over 3,000 active satellites in orbit. And the majority of these are from the United States. China has the second most number up here. It's hard to get the full tally of all the satellites up there, but I think it's over 3,000 at least. And a significant portion of those, everybody, are controlled by SpaceX. And Starlink is certainly about to overwhelm low Earth orbit. So that is a secret, a fun fact. I don't know what you want to, all sorts of things. So, but accidents. So what about this? And this gets into, you need to be paying attention to this. This is very important. So all these satellites up there, yes, they're doing some good things. Yes, they're running your cell phone and your GPS and running our lives and getting Netflix to everybody and all of these things. But is there too much? How much is there? Well, there's 2 kinds of collisions you might have up here. One is intentional, and that has happened a couple of times, where there's been an intentional destroying a satellite that can be for military purposes. And the second is unintentional collisions. And we're going to show you that. And that brings us to secret number 3, as well as this new data set, which Deion just turned on, where there's purple and green going around. And this is our secret number 4. Let's turn off the active satellites and just leave the debris. This is the debris from an incident that happened on February 10th, 2009. There were 2 communication satellites called Iridium 33 and one called Cosmos 2251, and they accidentally collided. They were moving at a speed of 26,000 miles per hour. Remember, you move really fast in low Earth orbit, and they were about 490 miles above Siberia. So that's fast. That's not good. And now what you're seeing is the leftover debris from both of those satellites. Deion, do you remember which one's purple and which one's green?
Yeah, so they're color coordinated. So the debris, we kind of attach it to the satellites. So the purple one is the Iridium 33, and the green one is the Cosmos numbers afterwards. But yeah, just from 2 satellites crashing into each other, it almost looks like a whole new network of satellites are covering Earth, which is kind of terrifying, but beautiful on this software.
Yeah, and so these are small pieces of those larger things, and so you got to wonder. There's something called a Kessler Syndrome that very many of us are worried about. That as these things collide, they make smaller pieces, and the smaller pieces start orbiting all over the place as well. You can get a trickle-down waterfall effect, where you get the Earth basically surrounded by lots of small debris moving very, very quickly, which makes it extremely dangerous to launch off the planet. Because even a speck of dust up there moving at 20, 30,000 miles per hour can be devastating to whatever spacecraft or whatever thing you're launching out. So now let's go into what this means for the sky. So let's pause here, Deion. And I want to show you from an astronomical point of view, because I'm an astronomer. I'm a research astronomer. I go to telescopes. I take data. I monitor the sky. How often do one of these things fly across our point of view? Well, we've got a cool video to show you. And this video is going to show you a combination of both the geosatellites and the low Earth orbit satellites. And let's hit play on this. These are going to be images taken by an amateur astronomer, which is showing you the nighttime sky where the stars are just held in place. And what you're seeing is those satellites flying across. Now, notice the train of satellites that is just below the belt of Orion. So this is I should clarify that. This is the Orion Nebula cluster, the closest young star forming region near the sun, where you have little baby stars forming. So it's a heavily looked at area by astronomers. And look at all of these satellites that are flying across the sky. You might know those are some clouds coming in, and this is going to show them accumulating. You'll notice the train that starts to develop in the band just below Orion. That's largely the geosatellites. Those are the ones that are moving slower, your telecommunication satellites. And then streaking in all the other directions, those are your low Earth orbit objects, and that's all trails after 4.5 hours. And now let's switch to the, we got Soleil back. Let's switch to the CTIO view, the view from a telescope that Soleil has. And the idea of monitoring your sky at all times to see if these things are up here. This is an observatory that I know very well. I did my whole PhD thesis here. And this is a very special place with some of the clearest, most magnificent views of the sky that you're ever going to see. And you're watching the telescope domes moving around as astronomers are inside, looking at the nighttime sky throughout an evening. The Milky Way is rising and moving around, and streaking across your sky are all of these satellites. And so what does that mean? Well, I mean, they're going to cross the astronomical object that you're trying to study. So let's show the deck cam image now, Soleil. And check this out. This is what's called the dark energy camera, which is surveying the deepest parts of the cosmos, trying to figure out what dark matter is. These images are expensive. These images are, I mean, they take a lot of telescope time, but all of those streaks that are coming across the sky that you're seeing, that's actually all Starlink. That's all satellites that Elon Musk has launched. And this was shortly after the launch, when they're brightest. They streak across the images. And as astronomers, we have to throw those images away. We can't use them because it's contaminated by the satellites. Let's do one more, the last one here, which comes from Lowell Observatory. And this shows yet another. And like if you look straight at the center of this image, the center, and then just to the right of center, you see these fuzzy looking things. Those are distant galaxies that we were trying to study. And streaking, like you would think that you were looking at a pattern in this. All of that, once again, is Starlink satellites that have streaked across these astronomical images. It is certainly a concern for astronomers. So now you have to worry about the collisions, and debris, and having too much stuff up there. But from an astronomical point of view, this is our nighttime sky, and we want to protect it, and we want to still be able to see the deepest, farthest objects. But if you have a bright satellite that you have to look past, it's really difficult. Okay, let's end with the following. And that is, because we've teased this out, that this isn't just the only debris that you have to worry about. So I want you to take this into consideration, especially young people in here, that maybe you guys will grow up to want to work for SpaceX. That would be amazing. But keep the nighttime sky always at the back of your mind in terms of protecting it, and come up with great ideas of how we can utilize the space around Earth, but also protect the sky by making these things less reflective, or maybe less of them. All right. Last kind of space debris that's also a teaser for our next program, and that is debris that doesn't even come from our solar system. And that leads us to the final fun fact secret that we have for you. And that is that in 2018, we had a visitor to our solar system, and that was an object that has been dubbed Oumuamua. It was discovered with a Hawaiian telescope, October 2017. And it was a rock, most likely an asteroid, that is entered the solar system on what's called a hyperbolic orbit. So it is not bound to the sun. We kind of realized it right away. It was coming in and exiting right away. And it likely came from a whole other solar system. So we're going to show you how that object enters.
Mhm.
Oh, got solar
Really
here.
quick, just while we're here, before we move too far away, we're getting a lot of questions about where the Milky Way is, and I can see it, and I thought maybe we should just point it out while we're here.
Yes, great question for those that are asking that. To give you the orientation, we've got the solar system set up right in front of you. And that stream of thick stars, where a lot of it looks like dark patches of cloud, that's the Milky Way galaxy, or at least that's the disk of the galaxy. And the reason why there's so many dark clouds is because there's a lot of dust in the galaxy that blocks us from being able to see stars, because it takes the light and it kind of removes it a little bit from your view. But here we are. We can move time forward. So you're oriented with the solar system. And in October 2017, in came a completely different kind of debris, not a satellite it did not become a satellite of our solar system. It came in, it entered the solar system. You can see the orbit that it was coming on was high from the plane of the solar system. It came at a speed that we recognized right away was not something that was going to remain bound. And then it exited. And it's on its way out. It's too far away for us to study in detail. And we've called it Oumuamua. It is, in its own right, a space treasure, but it's also space debris. And there it comes, another one. We can move time forward on that, because just about a year after that one was discovered, which kind of shocked and excited astronomers, a second object came in that's called Borisov. And this one looked much more like a comet looks like, but likely this is more material that came from a totally different solar system. So in the spirit of a program that's about space junk or space debris, we had to show you the natural kinds of space debris that might exist. And these aren't the satellites. This is not human-made. These are objects that probably came from other solar systems, entered our solar system, and then just took an exit. So very exciting, and that gives us a chance to promote too. If you're into this, if this sounds exciting, if you're like, hey, isn't somebody claiming that Oumuamua is an alien spacecraft? If you want to hear more about that, come to our program. We have a Frontiers lecture on this exact topic, and we can put this in the chat. It's in 2 weeks, so I cannot remember actually the exact date of it.
Yep, it's Wednesday, February 17th at 7 p.m. Eastern time. And again, we'll post a link in the chat so you can learn more and purchase tickets.
So that's a special kind of space debris. And we're excited to invite you guys to come to that program and learn all sorts of things about that. Oumuamua and Borisov and what they are and what they mean, and why everybody in the world is talking about Oumuamua right now. So let's end with the visual of Earth, though, and our satellites. And so if there's any other questions we can answer, because I know we're close to time, I'm happy to take a question now. Otherwise, we're coming in on Earth.
Yeah, I mean, there's so many great questions, but one that stuck, I'm trying to find it here, was actually about how satellites might affect climate or our Earth's atmosphere, just by like launching them out. Is our atmosphere, ozone layer affected in any way, or does this like having all these satellites up in space affect our climate in any way?
That's such a great question, and you know, I only learned recently that when they were first making decisions about launching rockets, a concern that was taken very serious was whether or not they could do extreme destructive, like almost blow up the atmosphere by launching rockets. And so that was something that needed to be investigated. But it does affect it will affect our atmosphere. How much? I'm not sure how to quantify it. It's not my area of expertise, but I know many that are studying this, the effect of launching rockets on the atmosphere of this planet. It's, of course, got a footprint of its own on many levels. So it is something that people look very carefully at when they're discussing this. I want to encourage you guys, because we're doing these cosmic these challenges even to get you away from your computers. If any of you live near, if any of you are in Florida, maybe some of you are in Northern California, you might actually be near where they launch rockets from. And they're pretty phenomenal to watch, rocket launches. I actually was at a launch at Kennedy just last year when they were doing a test of the evacuation of the Dragon capsule. And I went to the Space Center. I watched it. My mind was blown. I loved seeing it. And you guys can do it too, especially if you're along coast in California, can certainly see it from Vandenberg. If you're anywhere close to there, the Santa Barbara area gets great views. Florida, you guys have great views. So look up when rocket launches are happening, because they're also spectacular things to look for. And I think that's probably our program. I think we should wrap up there. Highlight one more time, though, that Deion is an amazing pilot, and Deion is a school teacher, came to us through the master's program, which we have an open portal for. And so we want to encourage you guys to apply. You could also be flying a program like this if you join our program or joining our research team. So we're really excited to promote that. Deion, any final words?
No, thank you for really joining us on that journey. I mean, you got to keep that plug going, just because we need more teachers. We need more earth science teachers specifically. We see that science is really on it's in news all the time, and you want to be a part of it. So I think just check out the MAT program, reach out to anyone in the museum, or check out the portal if you've got nothing to lose.
Thank you so much, you both. I learned so much here, and if you're in the chat, maybe put a round of applause from wherever you are tuning in from the world for our amazing presenters and pilot. Before you go, just a few announcements. Your feedback is so important to us. So if you have a few moments, we'd love to hear from you. Just go to this link. We'll put it in the chat. It'll only take a few moments. And of course, as Jackie mentioned, if you want to join us on Wednesday, February 17th for our Frontiers lecture, where we'll talk even more about Oumuamua and other interstellar interlopers. We'll put the link in the chat again for you to find more info. But my most exciting announcement before you leave is our next Astronomy Online, which you're going to hear it here first, is a grand tour of the entire universe. So we'll be blasting off from Earth, going past the Milky Way even, and beyond, hitting some amazing sites along the way. So mark your calendars for Friday, March 5th at 1 p.m. and join us right back here on AMNH's YouTube channel /YouTube Spaceship. Have a great day, everyone, or evening, and we'll see you next time.
Bye, everybody.
See y'all.